tried to show us last week that and we have varieties of them. We have the geom line, we have the geom point, and sometimes if we want to plot maybe some chart like the bar chart, the histogram, the and other ones. So we have the geom core, we have the geo east, and all of that. Then we have this statistical transformation, which are just optional. And don't forget that last week I mentioned that of all of these, four of them are very, very important, and they are the 1, 2, 4, and the 7. And I try to explain some of these things. And also we try to visualize a particular data set, which is built in, which is actually a data set in R. And I think I share the screenshots with us for us to try it out so as to see what the outcome looks like. And you will see here now that here we have the ggplot, and the data we are looking at is the hair quality. And just like I told you, I said that the data set, the data sets, sorry. All right. So I said the data set we are using. Uh, sorry, excuse me, I don't know why this one is popping up. All right. So the for the ggplots, I made us realize that um the data frame we are going to be using, that is what we import into the ggplots, and every other thing about the data set will be called from this data frame. That is why it's very important. Whatever data you want to work with, just put it in the data frame. Sometimes it can be in the CSV file with the column names. And don't forget that any data you call here, all right, if you call out the columns not existing in this particular data, you may run into error. So you want to be sure that every column name you want to work with are integrated into the data. That I'm still being heard. Please confirm that you can hear me.
Yes, we can hear you.
Loud
All
and
right,
clear.
all right. Okay, thank you so much. So now
Yes,
the
the voice is back.
aesthetic which you use for the mappings. No, now there are quite number of confusion that can be run into. So, and I think it's very important for me to explain that. Let's say, for instance, now you want to plot like what you plotted here earlier, like what we plotted here earlier, although there is no particular data set with which I can make that example, but let me just explain it theoretically. So like this data set that we plot here, from the here data quality, here we have temperature and ozone. Now, let's say, for instance, that maybe we have this data point that we have here. Maybe we have, let's say, for instance, maybe 3 classes of ozone, maybe layer 1, layer 2, layer 3, which is also embedded in the data frame. So, by the time we are plotting temperature and the ozone, is going to be on the basis of the zone layer, maybe layer 1, layer 2, layer 3. So sometimes um, you want to distinguish between these layers, even in your data point. Maybe, for instance, every ozone layer, maybe in layer 1 should be painted blue. The one of layer 2 should be maybe 3. The one of layer 3 should be maybe yellow or green or black, as the case may be. So in that case, in this aesthetic function, you will just put color equals to layer. Maybe the name of the layer is name of the column is layer. So by the time you plot that, what you are going to be seeing here is just going to be those 3 different colors according to the unique layer types that we have under that data frame. But in a case whereby you want everything to be all the same without considering there maybe differences or maybe the unique types that you have under a particular column name. So that one you can do it outside the AES. And that is why if you look at what we did here, we said geom point color, let it be this particular color, which is like reddish in color. And that is why for all the data points here, all the data points that we have here, we are seeing that they all have the same color. But if we have 3 types of this particular data set, maybe according to the layers of the ozone, maybe layer 1, layer 2, layer 3, just as an example. So we declare the color inside the ozone. And don't forget, if you are putting the color here, we are going to be using the column called, let's say, layer, as what will be used to distinguish between the three type of layer that we have. That's just an example in order to distinguish between using the color within the AES and outside the AES. So now this is the rule. If a visual property depends on data, a visual property like the data point that I've just shown you, if it depends on the data, we put the color inside the AES. But if it is a freestyle choice, we put it outside the AES function, which is the aesthetics function. So we are going to see this maybe it's a typical example of that in the next example. So the house script I sent to us contain this DHEP monthly data frame. So please, we can just check that on the data, the house script I shared with us. If you scroll up to yes, line 134, just like I have in my home kit here. I have build the DF monthly from our vector. So, and in that data frame, we have the month, which is from July to December. We have synthesized data of cases of malaria, let's call it that way, and also synthesized data of rainfall, each of them just for 12 months, which represents a year each. Okay. So now one of the things you want to be sure of is that please run all the codes line by line up to where I am, because if you have not done that before, you know, it's a new script that you are just going to be opening. So you have to run all the code up to this stage, or up to the stage I'll be running henceforth. So in order to follow me, because if you just start from here and you just run and all of that, some things may not just work. Why? Because some of them depends on previous declared lines of code. Okay, so you want to be sure that you have run the script up to this particular stage that I am. So I've just shown us the DF monthly data. So now here we want to plot the DF monthly data. So we are saying let our X be the column name, which is month, and Y be the cases, and then fill with cases. So now what we want to plot here, actually, we want to generate a kind of bar plot. And now you will remember that for the bar plot, it's going to be coming out in rectangles, in vertical, vertical rectangles. So now, because we don't want the color to be all the same. We don't want the color to be all the same. So one of the things we're going to be doing here now is that, okay, so what we are going to be plotting here, fill them with cases. That is what you are seeing here. So that means different case, we have different color. Different case, we have different color. That is what this one here means. What I was trying to explain the other time. Normally, RDB is just a kind of data point. You are just going to have maybe several points with several colors. But this time around, we are plotting a kind of the bar chart. All right. So, and we want the vertical rectangles to be filled with color according to cases. So you will now agree with me now that the color of the bars is dependent on the column name in our data set. So for instance, if I should run this line of code, okay, and I call P alone, for instance, like I said, if you have run that line of code, you can just highlight P and run it by pressing Ctrl Enter, or you click on Run after highlighting it, and then you're going to get the output. Now, if you see from the output here now, you will see that from January to December, we have quite different colors. We have quite different colors. Why? Because we have said that somebody is writing on the screen. I don't know, maybe the person click on the pen and is writing on the screen, because I can see something like that here. So please, the person can just do well to help us clean it up. All right. So now, like I was saying, so you see here now that what we're actually plotting is the bar chart. Okay. But we have said that fill the bar chart, that is each of the bars according to the cases. And that is why you are seeing here that each case has its own unique it has its own unique color. Let's say, for instance, now if I should remove this field equals to cases, let's say, for instance, if I remove field equals to cases, let us see what is going to happen. All right, so if you press this hold down, so can you see now that here now, because I have not declared that, please fill the bars according to the cases, all right? That is, each case has its own particular color. So that is why you are seeing all of them now have a kind of gray color, because I didn't declare that let the bars have their color according to the cases. So you will now see that on the other or the former one, the colors of the bars are dependent on the column names. All right. Let's say, for instance, now another thing again we can do. I don't know. Can you still see my screen? Because I'm seeing. All right. Okay. So let me share my screen once again. All right. So can you see my screen now? Please, I want to confirm that you can see my screen.
Yes, we can now.
All
Yeah,
right.
we
So
can
I
see
also
it.
want to confirm that I'm not running too fast. Are you following? Are you getting it?
Yes, sir.
All right. So now, but let's not take for instance, maybe I want to declare the color. Maybe I want to change it to something else. Let's say something like blue, for instance. If I should run this now and I'd like and click this, we are going to see here that I'm seeing everything here as blue. Okay, let's see something. Will this one work? I'm not so sure. Hmm. Okay, I'm not so sure this is going to work. Let's see something here. Yeah, this is not going to work because. All right, so yeah, now you will notice here that because we are working with bars, you will see that the borders of all the bars are colored blue. Okay, okay. So if I return the fail, let me remove this guy. If I return the field according to cases, then that brings me back to what we had formerly. So, and that's, we are going to get it back, all right? So that's that about that. So another thing again we can do is that we want to plot the rainfall, which is the second one here now. You can be trying some of these things at your hand. Please, let me be sure that the code also is running at your hand. Please, I want to be sure that the code is running at your hand.
Yes, sir.
I've only heard from one person.
It's running.
About 78 participants, and I've only got responses from 2 people. I'm seeing response from Uche, only 3 people. So that means others are in the kitchen or something.
We are with you,
Seeing
sir.
from
We're still trying to.
Yeah, that's the response I want to get. I want to know that we are on the same page. I don't want to be in page 100 and somebody is still on page 1. I want to be sure that we are on the same page, right? Are we on the same page now?
Yes, on the same page.
Okay, because I'm seeing 79 participants and only few are just responding. Possibly some are busy in their offices or something.
We are trying to follow you.
It's okay. Yeah, so yeah, I know, but I want to be sure that even in trying to follow me, that we are on the same page now, that we are working side by side. Just like in the physical class, people don't really talk like that.
Well, I think like most of us, maybe someone like me, I'm not where I can really walk, but I'm following. So what you are doing is sinking in. So later I'll go back. So I think you may go ahead, sir.
It's okay. That is confession time.
Yes, sir. Hello. Yo. Yes. And I'm discovering too that your number of lines is slightly different from ours. I have to minimize both screens. Saying that, like my number
Yeah.
196.
So yes. So just run from the
98.
line 1 up to that place so that you'll be able
Okay.
to follow from where we stop. Yeah.
Okay,
You'll be able
no
to follow
problem.
from where we had. Yeah. It won't take you much time. Just within 2 minutes, you are done with that. All right.
Okay.
It's okay.
Okay.
All right. Okay. All right. Then we have the likes of Unwem, Zays, Zenal, Bolaide. Are we together? I want to specifically mention people's names to know if they are really here or not. I'm seeing Sharifat or Joe Lawa. Are we together? Saliu or Abdurrashid. Are we together? Kena Yannick, Yiho from Benin. Are we together?
Yes, I just started from Benin. I'm running everything.
Okay, so you can see now I'm discovering people. I'm already catching them one by one.
Yes,
Okay,
I'm with you.
So many
All right.
things.
All right.
It's okay now.
All right. So I'm
Sir, can you
seeing.
scroll up a little?
I scroll up a little. You have to be
Yeah,
scrolling on your
before
own
the
screen
bar
now.
chart, monthly cases, because your workspace is it shrunk, or I don't know how to use it. It's minimized. I want to see a hand. Then go up a little, sir, please.
What do you really want to see?
Yes. This go back, go down. Like line, yes. Here. Oh God. 92, 192, 191, 192. Yes, thank you.
Yes.
Yes, thank you.
It's okay.
Yes,
Please,
I've been able to
please.
down the code.
You are not to be typing the code from here. I've sent the out script on the WhatsApp group, so you have to just download, open it, and run at your hand. I'm not going to be waiting here for you to type all of these things. I've already sent the out script. What you are seeing here, I've sent it also to you, so I'm only explaining here. Please, let's get that correct.
I tried opening it on my laptop. It didn't open.
Go
That's
to
my
R.
challenge.
No, it's you
Open to the
open.
R studio.
It's your open. It's your open. Go to your Art Studio. It's your open. From your Art
And you
Studio,
see
you
the
can click on.
file.
You can click on File, Open File. Possibly, maybe if it is inside your downloads, so you can go to your downloads to get it there. Then just click on it, open it. It's going to open.
Okay, let me check and do that.
Yeah, I'm really happy that I'm not assuming people are following me. Right, I'm seeing one Boluwati first. Sorry, I'm very sorry if I'm not addressing you by Professor Doctor. It is because I'm not seeing that here, so I don't know who is who. So please just permit me to call you according to your names. All right, let's assume we are in US. So we have Lee Abubakar. I want to be sure that we are together. I'm seeing Ayedun, Tomisin, Boluwati Fair. Are we together? I'm not hearing responses from these people. Daniel Akinyemi, I want to hear you. Are you there? Are we on the same page?
Yes, sir, we are with you, sir.
No. Say I am with you.
I am with you, sir.
That's very correct. Because it's just only you. Because I don't want anybody to speak on behalf of others. All right, I'm seeing Felix Eli Wang. Are we together? Some of the people I've called, I've not heard from them. Ali Abubakar.
I was the first that responded.
Oh, that's very good. That's very good. Thank you. Adibi Delightful, are we together? Abidoye Toluwani Elisha, are we together? Abdulatif Lawa, are we together? I've not heard from these people. I've called their names. It's all right.
We are together.
It's all right. So, okay, Benita, are we together? It's okay.
Yes,
okay.
sir.
So, it's all right. So, means I can continue now. Somebody is saying I don't have access to the WhatsApp group. Wonderful. I don't have access to the WhatsApp group. I don't know. I will not be able to share it here, so I don't really know. It's possible to share. So how did you? Okay, the link. So the person that just quickly that said he or she is not on the WhatsApp group. How did you get the link to join this meeting? So possibly you want to check that. All right.
Sorry, please, I think I need guidance. You said we should, after downloading it, we should go to
Yes.
file.
Go to
Go
file.
to the studio.
Under
the
file, you will
studio.
see open file. Open file takes you to your file explorer where you can explore where you downloaded it. Maybe it's on downloads, so just check. So when you have found it, click on it and click on open, then you will see everything wide open on your House Studio.
Okay, for file.
All right, so I would like to continue now because I don't want us to waste so much time also on that. Okay.
Please, sorry, kindly, excuse me, kindly share the file again. We have tried to
The
download
what?
several times. It's not downloading.
It's not
Kindly
downloading.
share that file again. The arrow
Okay,
malaria
somebody is going to
workshop.
reshare on my behalf. So please
All
let
right.
somebody kindly reshare on my behalf. Somebody is going to do that. All right, so another thing again you want to do is, let me copy this, the entire code. So I'm going to be pasting it on the chat box if it can contain it. I don't know. I think the chat box may have its own limits. I think it can only take 1,000 characters, so I don't know. I think that's not working. All right, so maybe. Okay, so let's continue. Yeah. Okay. So we have, so for the second one, we want to plot the line plus point chart for rainfall. Now, what does that mean? We are going to be using two plots here. We are going to be making use of the line. We are going to be making use of the point also. I think we did something similar to this last week, where we used both the geom line and the geom point, okay, to visualize the rainfall. So now if I should run this, I'm going to be seeing the monthly rainfall. So you can see it is both line and also point from January to December. Okay, and you can see the label layer. We use this to label. We have the title. That is what you are seeing here. Title is what brings the title monthly rainfall above here. Okay, and just like as I have told us earlier, using the ggplot, this is the data set where we have these columns, month and rainfall. Okay, and then you say group just one. Okay, then we have geom line color. This is just the color, the line width. Because it's line, you can increase the width of the line. All right, yeah, that one just give us how thick the line is going to be. If I say 1.8 or 2.0, for instance, it's going to be thicker than what we are seeing here now. Okay, let me just say P2 here so that I can just easily run it. So you can see it is thicker than the former. Okay, that is what the line width does. Let me just change it back to 1.2. Okay. All right, so then for the geom point, all right, you can use the same color, and you can also change the size of the geom point. That is, these points here, each of these points, you can also change their size, just like what we have here. If you increase it to 5, each of these points will be bigger and larger than what we are seeing here. Then for the labeling, we have the title of the plot, which is what we have here, monthly rainfall. Okay, if you don't need it, you can just scrape it out. Okay. Then for the x-axis, if you want to label the x-axis, you want to change this one from null to something like, let's say maybe time, maybe time in months. Okay, so if I should run this now, you'll see the x-axis is going to be time in months. Okay, but if I don't want to put anything there, I can just put it as null, meaning nothing. Okay, all right. Null is a German word which means like nothing. Okay, so then we have the y-axis, which is the rainfall in millimeters. So you are labeling the y-axis under the labs layer, so you can see. And I told us last week, whenever you want to add any layer to the ggplot, you do that with plus. Then we have the team workshop. This team workshop has been predefined earlier while I was explaining last week that is what we use to get the same layout for our graph area. so that everything can be consistent and also unique. All right. So another thing again we can do is that we can do what we call um, patchwork or operator stacks. What that means is that you want to stack two plots as layers, one over the other. For instance, now we have plotted P1 and P2, which are the bar plot and also the line plus points chart. So if I do P1 over P2, just like what you are seeing here using the forward slash, we are going to have the two plots on each order. So just like you can see monthly malaria cases above and then monthly rainfall below. And now one of the things we can also learn from here is that you will now see that the last plot is the one having the name, the label for the x-axis. So let's say, for instance, we want to have 3 or let's say maybe we have them to be 3, which I'm going to give you as an exercise now. Maybe for the first two, you want to ensure that the X is taken null, that is, don't label the first one, just like we see here. But for the second one, just like what we have in this place, then you want to say, okay, maybe you can go on to label it as time in a month. Okay, so we have time, month. So if I run this again, and I run all of this over again, so you're going to be having time in months. But if I don't pull that, if I don't pull this here, for instance, maybe if I just put it this way, also this also works. So we are going to be seeing that for the x-axis, we don't have anything. We don't have anything on the x-axis, but we have to put something there to show what the x-axis also represents. So now, one thing I want to give us as exercise. So I want to be sure how many of us are on the same page now. I only need maybe 1 or 2 people to give me a response that we're on the same page. Let's go on to have them. First 2 people to give us that we're on the same page. Okay, I've seen Anolua, we're on the same page. Who's going to be the second? I've seen Zaid, that we're on the same page. Thank you.
We are there.
All right, so now
we're not getting the graph you're drawing. Well, I am not getting the graph you're drawing. Sorry to interrupt. I don't know what the issue is.
Can you tell me what you are getting? Can you be more specific?
It didn't even show me. It didn't even show me any graph. I did was I copied
okay. Now, maybe possibly because what we have just done here is that we assign this plot to P1. So if you're not running P1 separately, maybe like P1 and you run it, you may not see the plot. So you want to either say flex P1 or you just put P1 and run that line, then you are going to see the plot. But if you go on without doing P1 and that P2 and you just put this here, you should have the last plot I had before this one, this particular one. Right? So now another thing I want to tell us is that we can stack more than 2 plots on each order. We can have up to 3, maybe like saying something like P3. You can have it like that. So I want to give us this particular exercise. So we have cases and rainfall. So let's take a look at, let's set seed because we want to create, let me say 4, 3, 2, 1. Now we want to create another data. We want to add a column to that data set, for instance, and that column is the DF monthly temperature. We want to add temperature to heat. We are using this run if, meaning we need 12 points and we want the temperature to be between 23 and 35. All right. Okay. So another thing again, apart from putting them up, okay. So now, okay, let's just do this. Okay, so let's just do this. So let's create this particular data set. We want to add it to DF monthly data. So now one of the things we want to just do here is this. You can use this to create a column name to be added to this DF monthly data. So how do you do that? Just do DF monthly, use the $ temperature, which is the new column you want to create. Then you are assigning that to run if 12, beginning from 23 to 35, saying that give me 12 values within the range of 23 and 35, and that becomes our temperature value. So, and after that, the next thing I want you to do is to plot the output of that. But don't forget to set seed because we want to create something random. All right. How many of us are doing that already? I want to be sure that some people are doing that. Can I hear you, or you just just click on any of the emojis? All right, I'm seeing Anolua.
Sorry, sir. I have a question, sir. I don't know if you can hear me, sir.
All right, please, you can actually interrupt me to ask your question. Yes, go on.
I'm sorry, sir.
Go on with
Can you
your
hear me,
question.
sir?
I can hear you
Okay.
clean and clear.
I have been trying to run. We have been trying to run the graph from our side, but it's not running. It's not showing anything.
Well,
Can you hear me, sir?
not running.
Can you hear me, sir?
I have done and it's not yet running. So I'm asking that, could you please be specific about what you are running and what is not coming out? You may need to be specific.
Yes, the bar chart for the monthly Maria cases, when we ran
so
it, it's not bringing up anything in
what
the
have you tried to
area.
do? Have you tried to call out P1 by running this line? Or you do something like print P1? Have you tried to do that?
Okay.
So one of the things you need to understand, please let me quickly clear something here. Let me quickly clear something here. Very, very important for you to understand the R code. Now, me running this, if I just run this, nothing is going to come out. The only thing I've done here is that this visualization, I've assigned it to P1. So me running this is not going to output for anything unless just like when you say X is assigned to 3. If you should run that line of code, 3 is not going to come out until you call X. Please, are we getting that now? So unless I say print P1, or I just run P1 itself, maybe by highlighting it and running it, or I just bring it here, P1, and I run this line, I'm not going to see anything. Because what this one has just done is that it assigned this ggplot function just to this P1 variable. That is what it has done. So we need to understand that, please, in case we run into a similar problem. All right. Okay, so can I continue? So so you want to try that for P1 and P2 to see. So before we add this P3, like I was saying, so how many of us have created this? Let me see your emojis if you have done this. And here we have the P3. All right, so here we have the P3. So you don't need to type all of this. Please get it right. You don't need to type all of this. Just copy the P2, put it here, change it to P3, then change some things. You have months, change rainfall to temperature. That's just what you just need to do. Monthly rainfall, change it to monthly temperature, X time point. That's just what you need to do. You don't need to type everything all over again. Just copy the P2, put it here, put P3. Just edit one or two things to suit what is here. That's all. So please, we have less than 2 minutes to do that. After 2 minutes, I'll be moving away from here.
Sorry, sir. I'm still finding it difficult to print this graphs because it's telling me initially it said monthly not seen. The DF monthly not seen. I've gone to copy monthly. I've run it, and it's now saying in Teams workshop could not find function. I don't know what that meant.
You're saying what?
in error in team underscore workshop could not find function. And I've not been able to print any graph.
On the chat box. All right, respond on the chat box. Thank you. All right, so now another issue again is any problem you have, any error you have, any error message, please copy it and put it on the chat box. We have part of our account that will be responding directly to you through the chat
All right.
box.
Thank you.
Thank you. So, all right, so how many of us are done with P3? I just need one emoji, and with that, I'll be fine. Thank you. I'm seeing that from Isaac Olu something. Sorry. All right. So now, if I should run P3, and I do here, so you can see running P3 is not outputting anything, just like the complaint somebody made. Reason being that I only assigned the GJ plus function to P3. I've not called out, or I've not run the what the P3 itself contains. So if I do P3 and I run this now, I'm going to see what P3 contains, as you can see in this place. All right. So, and now we want to patch it, or want to stack them together, P1, P2, and P3. Okay. If I should do that, you see that we have stacked the monthly cases, rainfall, and temperature. We've stacked them together. And another thing we can do again is that we can place them side by side by using this vertical line on your keyboard. So I don't know where it is on your home keyboard. You may want to find it. So if I do this, I'm going to have the three of them side by side, as you can see, side by side. I can decide to zoom it, so you can see it clearly, right? So you can see them side by side, right? So depending on the one you want, you can stack them upon each other, and you can place them side by side by making use of this vertical symbol. It's visually on top of the backsplash if you are using my own type of laptop. So I want to check. So whichever one you want to stack it one on each other, or you want to place it side by side. So this one is side by side. Then this one is stack each other. Okay, to do this, stack on each other. If you do this, place side by side. So how many of us have been able to achieve that?
Been able to achieve that.
Okay, I'm seeing quite a number of people. Tijani Kazim, Anu, somebody who have just responded. Okay, Isaac, Abdul. Okay, I've not heard anything from others. I'm seeing Salil. That's very good. Okay.
We can
That's
also
very good.
use plus, right?
You can also use what?
Plus.
Plus, like
P1 plus P2.
Try it out. Let's see what the outcome will be like. Can go on and do that. No,
Yeah,
one thing is
it
it's not
worked
just
for
about
me.
here. So fine. So fine. In coding, you also discover new things. All right. There are different ways of doing the same thing. So if you have discovered that, very good. It's part of learning. Thanks for pointing that out. Somebody said if you also use or make use of plus, something like that. So let's see. It's also going to work. So we are learning. So just like you can see, right? So that leaves them side by side. So yeah, so fine. Okay. All right, so can we continue? I only need one yes.
Yes, sir.
All right, thank you
Yes.
for giving us that yes. So now the next thing we want to go on to doing is writing your own function, which is very important. So how do we define function in in R, so for function in R, we have the keyword which is called function itself. So, and that is what we are seeing here. So here we have a template. So you can see my function. All right. Now you want to create a function. So, and you are assigning that function to a variable name, my function. Okay. And then your function is taking these arguments, which are your inputs, input 1, input 2, right? Let's say, for instance, now, I remember when we were in secondary school, there's this formula we call almighty formula, even though there's nothing almighty about it, that we use to solve quadratic equation. We want to find the root of quadratic equation, which is negative b plus or minus the square root of b squared minus 4ac over 2a. So you can write a function. You can use that formula to write a function to find the root of any quadratic equation, actually. So what do we mean by that? That means if you're going to write a function to do that, one of the things you want to supply are the coefficients of the variable and also the constant, which are the a, b, and c. You know, a for the x squared, b for x, and c for the constant. So now when you plug that into the formula, which is the negative b's plus or minus the square root of b squared minus 4ac over 2a, you know, it's going to work on that, and then it will return the result, and that is what this one is doing here. So after you have defined the function, how do you get the output? So you print out the output using this return function. So return the results. Let's say, for instance, now maybe you want to do something like a function to find just like what we have here. Okay, so maybe another thing again you can do is that you can have default arguments. For instance, now I have here input 1, input 2. Possibly I'm going to be having input 3 in the function I want to define, and I want to have a default value for that particular input 3. I can say input 3 is equals to 4, for instance. Okay. So this one here now, even though it's going to be appearing in the function, I don't need to declare another value for it. Reason being that I've already assigned a default value to it, which is input 3 equals to 4. But for input 1 and input 2, not assigned to anything. What it means is that they are more like a variable. That is, I can assign several values to them, and that is going to be giving me different outputs. So let's say, for instance, if we want to compute the basic reproduction number, which here, a simple one we define as beta over gamma. All right. So now, how do we do that? We know that beta and gamma are the parameters in the basic reproduction number. So this is the formula for the basic reproduction number we want to compute is value. We have R naught equal to beta over gamma. So now, to get the value of this R naught, it must be that I must have supplied the values within the function argument, which is beta and also gamma. And by the time I run compute R naught, is going to give me the particular value. So now we need to understand that because this function have been assigned to compute R naught, if I want to find the R naught, what I'm actually going to be calling will be compute R naught. And it is this compute R naught that will take the value of beta and gamma. Let's say, for instance, maybe we want to compute R naught. Let me first run this to be sure that we are okay. So we have a sample here. So we want to compute R naught. Don't forget, R naught is assigned to this function. Function, and this is to return the particular result, right? All right. So now let's not take, for instance, we want to please. Am I still being heard? I want to confirm that I'm still being heard.
Yes,
Yes, sir.
Please,
Yes.
are you following what I'm saying? Are you following it,
Yes.
or am I talking too fast? All right. Okay.
It's
So
all
now
right.
one of the things. Okay, thank you. So now one of the things you want to see here, because we have assigned this function to compute R naught. So this is what we'll be dealing with actually, because this is what the variable name taking that function now. So now the function takes into arguments which are beta and gamma. So we are not saying that let our beta be equal to 0.3, because before we can compute, we must supply the values. Let gamma be equal to 0.1. So if I'm going to run this now, so now you can see here we have 3, meaning that, and what has this done? What has this done? What it has done is that because we have entered this argument, it goes back into this function and put beta equals to 0.3, gamma equals to 0.1. And by the time you do 0.3 divided by 0.1, you're going to be having the answer as 3. How are we following?
Yes, sir. We are following. Yes,
Yes,
sir.
we are
Yes, sir.
following.
All right.
We can
So
still
now,
change the default value.
yes, you can change this value. Let's say, for instance, maybe beta is equal to 0.02, let's say, for instance, and then gamma is equal to 0.001, for instance. So if I enter this, I'm going to be having 20 as my answer, right?
I
It's
mean,
just
the
like what I
default,
said. The what?
the default value.
No, so for this particular function now, we don't have any default value.
Ah,
Nope,
okay.
we don't have any predefined default value. Let's take, for instance, now, if we have a default value here, maybe gamma equals to 0.1, for instance. So what that will mean is that I don't need to call gamma again within this function, right? I don't need to call gamma, sorry. We'll just do gamma, all right? I'll just say gamma, all right? Oh, sorry. Hold on. In beta gamma, yeah, la, la, la. Okay. 0.1, right? Okay, because that's the predefined value. Okay, but yeah, so another thing again is let's say if I change this to be this, I'm going to be having this. All right, but now let me explain what is going on here. So now you will remember that in some of the arguments I showed you last week, maybe of some typical functions, some of the arguments has their default value. For instance, now some of them are logicals, where you have the default value as true. But depending on what you want to do, you don't want that default value to be true. Maybe because you want something to appear, you can actually change it to be false. Are you getting it now? So a typical example, let me say something like geom. Let me show you a typical example of what I'm saying so that you can get clearly what I'm saying here. Let me say geom point, for instance. Let's get a question mark on this. So now, one of the things you want to see here is look at this geom point, for instance. Look at the geom point. You will see that it has several arguments, isn't it? You will now notice that you can see show legend is saying not applicable. Inherit AES is saying true. So these are like the default values, which if you don't supply anything, these are the what works underneath. These are the things that work at the background. Okay, these are what works at the background. All right, right? But now, if you want to modify, you can just change this to be false. Then that's going to be modifying whatever you're going to be seeing as your output. And that is why you will see here, when we change this guy to 0.6, we are having our answer at 0.003. Why? Because we have changed the value away from the default itself. All right. So I don't know if that is clear now. Right. So now see what is going on here now. What's the person actually asking? A package for this?
Yeah.
Okay. Okay. You defined. Yeah. Okay. Custom function. Okay. So I'm just getting your question correctly now. So now I need to also say here that this function we have defined here is not coming from any package. It's not coming from any library or whatsoever. This is a constant function that you have defined yourself. We define this function ourselves. Please, are we together? Hello, are we together?
All together.
All right, so we define this ourselves. So this one is not coming from any library or anything. Okay. So now, just like I was saying, because we have set the default value as gamma, if I should run this now, okay, and I just run beta. So what this one is going to be working with now is going to be working with this beta 2 and then 0.1. But if I don't want to use 0.1 again, maybe I want to change it, then I can come here to say gamma equals 0.3, for instance, or 0.4. The answer is going to be different. Why? Because I've modified the gamma away from its default. So that's just that about that. So now let's take a look at the function 2, which is what we have here. So you can play with all of these things at your hand. So our time is actually up already. We have just 3 minutes to round up this particular session, but I want to believe that we have learned quite a number of things in the course of this particular R programming, and today may be our last class. All right. So now the next function is we want to look at the IRS winning effectiveness, which is the indoor residual spraying winning effectiveness. You remember the class that you took on mathematical foundation for infectious disease modeling. One of the functions that was explained was the IRS winning effectiveness, which can be modeled using exponential function. This time around, a Gaussian curve. Okay, and the Gaussian curve you will now see here. The Gaussian curve is what is defined here. This is the Gaussian curve. All right. So we can write this mathematically. This one is just like P, maybe the peak, you can make it P times exponential minus T peak all squared, everything upon 2 spread. This spread sometimes can be sigma all squared. So that is like the function that we have in this place. So now in your function, there are quite a number of things you have stated in your function 1, which are your arguments, time. You have predefined the peak to be 1, all right? The T peak to be equal to 0. So the peak is just like the maximum winning, the maximum effectiveness, the IRS effectiveness. So here you are saying that it is 100%. That is the peak, which is 1. You are saying that it is 100%, but over time, it's not going to be remaining 100%. Why? Because the effectiveness is going to wane. Now, you may just want to picture it like maybe some of the insecticide that we use at home, maybe to kill mosquitoes or cockroaches, something like that. You agree with me that on the first spray, it's going to kill a lot, but over time, you will see some cockroaches dancing around your cupboard or all of that and enjoying themselves. Why? Because the effectiveness of that insecticide has waned just within very short time. So just picture it in that manner for IRS that we spray on the wall in our rooms in order to kill the adult mosquito who will be resting on the wall after successful blood meal. Okay, so this reigns over time, and you want to capture that behavior using mathematical function. But now you want to plot the behavior. So how do you go on to do that? That is exactly what you are trying to do here. To do that, you need to create a function. So with the aid of the function, you can generate data, as the case may be, over a particular time span. All right. So, and that is what we're just trying to do here. So we want to define the function for the IRA effectiveness as it wanes over time. Okay. So here we have T, which is the time. And that time can be, depending on you, it can be 2 years. If it is going to be on the monthly basis, it can be 24 days, it can be 24 weeks, depending on the units you use. So Messi Okpayinka, you are writing on the screen, so you may want to check that and also help us to clean it. So then we have the T-peak. The T-peak is just talking about the time when the effectiveness is at its peak. So let's assume this is the first time we are doing it. So that means it's going to be at its peak at 0 time. That is the starting point. Then the spread talks about how fast it rains or how slow it rains. The spread controls how fast or how slow it rains. So that is what the spread talks about. So, and with that, we have defined that. These are the parameters. So these ones now, spread, T-peak and peak, they are default values that have already been predefined. Although, like I said, you can modify them. All right. Then we have the time, which we will need to define. And that is why we have T-months. So our time is monthly using the sequence function 0 to 24 by 0.5, meaning let's have the time length from 0 to 24. All right, but with the step length to be 0.5. That means if we have 0, the next one will be 0.5, 1, 1.5, 2, 2.5, up to 24. Okay, so and we define that as we assign that to T-months. So now we are assigning this function to effectiveness. So we call the function, don't forget, this is where we assign the function, and these are the arguments it can take. All right, so for this time now, we have said our time is the T-months. So you can even say T equals to T.
So, sir, we can't hear you again, or it's just from my end.
Yes, I want to be sure I'm still being heard. Please confirm that you can still hear me.
We can hear you now,
sir.
sir.
We can hear you now.
We can hear you now. You
Please.
went off at a point.
You went oh,
We
okay,
can hear you.
All right, thank you so much. And then I also want to confirm that at this stage, we don't have questions. If you have questions, could you please signify now or just unmute and just ask your question now? I'm giving that room. All right. Like I said, you can interrupt me while teaching to make things easier for us, so that it won't be as though somebody who forgot his phone at home got to a particular bus stop, remembered, but didn't tell the driver until they get to the final bus stop and say, oh, I forgot my phone at home. No, that's going to take a long time for you to return back home to take your phone. But in the midst of the journey, you can interrupt the driver that, oh, I left my, so you can easily go back home to test it. So the same way,
Yeah.
you can interrupt me.
Please.
Right.
Yeah, let me ask you a question here. Now, when
All right,
you are
thank
defining a function, all right?
Yes,
all right.
yes.
IRF effectiveness. Now, if I
Yes.
understand you well, the function is a function of T with all these
Yes.
other variable, all these other, I don't know
Yes.
whether they are parameters
Yes.
or there is
Yeah,
a
there are
function
parameters.
of
Yes, parameters.
so
Yes.
peak equal to 1, T peak
Yes.
equal to 0, spread equal to
Yes.
6. They are all parameters, isn't it?
Exactly. Exactly.
Okay. And then, all right. So the function is
There
defined.
are parameters that exist within that function. Let me give us.
All right.
So let me. Okay, I think that is clear, right?
Yes, it's clear. So the function is defined as peak times exponential minus T minus T peak, all raised to
all
power
squared.
2. All right.
Yes.
Okay. So then, is it all divided by?
All over. Yes. All divided by. Yes.
So the exponential is divided by this.
Yes.
The exponential function.
No. Not that the exponential function is divided by this. Everything is part of the exponential. See, if you look at this first parenthesis here, you will see that it's connected with the last. So everything here is within the exponential function. Everything is within the exponential function.
Okay.
Right?
It's clear. It's clear.
All right. Thank you.
Yeah.
Okay, so
Thank you.
here we have defined the IRS effectiveness. We say let our time be the T-months, let our peak be 0.85. We are now redefining those away from the default.
Yeah, hello.
Hello, I'm with you, sir.
Good. Going back to what Madam was saying, we have the function, we have the input, right? So the input, we have T, we have peak, we have T peak. And from the other time last week, what we learned in defining function, you didn't capture any part where you have inside the inputs, there are assignment of numbers. So for example,
Okay.
I was expecting to just see T peak, spread.
And spread, of
Then
course.
later
Of
on, we
course.
can define those things. So I don't
Of
know
course.
if
Of course, it's still
why
correct.
are we having peak is equal to 1?
It's still correct. If you do it that way, it's still correct. You
Okay.
can define it that way. It's still correct. All right.
Okay.
It's still very, very
All right,
correct if
that's
you
fine.
define it that way. Great. But what we just need to note is that sometimes you want to define advanced functions. Okay. You want to define some advanced function where, okay, let's take for instance now, I don't know, if you go back to physics, where we have the gravitational force, universal gravitational force, which is F equals to gm1 m2 over r squared, for instance. All right, you will agree with me that part of that particular function, there are some of the parameters that are constant. Let's say that g is constant. Though I'm struggling to remember what is represented, maybe 6.67 times 10 to the power minus 11, something like that. It's constant. So if I'm going to be defining that function, because that g of the m or the g in that g m1 m2 over r squared is constant. So in my function, I'm just going to put that g equals to 6.67. I'm trying to remember times 10 to the power minus 11. So it's going to be constant. I don't need to be defining it again by the time I want to use the function. So the only time because I'm going to be interested in now will be the M1, M2, and the R. So that is where that is very, very applicable.
All right, thank you. Well understood.
Do you get what I'm saying now? All right. So, okay. So then we have, so I think this one is clear. So we have redefined the parameters here. So the next thing you want to do is now to plot it. So now,
We can't hear
there are
you
two
again.
ways. Can you hear me now?
We can hear you, sir. We can hear you. We can hear you, sir.
I think it's from
on
our
my end.
network. We can hear you.
Okay.
Can hear
Okay. Thank you. All right. So now the next thing you want to do now is
Lost you.
We can't hear you.
We can hear you, sir.
Please, can you hear me now?
Yes, sir. We can hear you now.
Yes, we can hear
All
you.
right. All right. Okay. Thank you. I really appreciate your response. Our people are now more active. This is very, very interesting. I wish it had been like this from the beginning. All right. So now we have, so, before we can make use of the ggplot, I told you we need to create a data frame. So we are doing two things here. We are creating the data frame and bringing it inside the ggplot directly. Now, one thing you can do is that you can take this out and say maybe df, assign it. Okay. You can assign it and just create it. Are you seeing it now? I've just created it that, okay, data frame. I want to bring my output from the function and the time, t equals to t months, the output of this effectiveness over this period of time. Everything is going to be, if I should run this now, let's say for instance, t months. What's going on here? Okay, we have not run this. All right. Okay. So now, if I run this df now, you are going to see can you see what is here? You are going to be seeing the effectiveness of IRS over time. Are you seeing that? You can see the effectiveness of IRS over time as it wanes over time.
Yeah, we can
Are you
see.
getting it now? As it wanes over time. All right.
Yes,
Don't
sir.
forget that now this is 0 to 24 by 0.5. So we are going to be having about 49 points. So that's why you have here 49 points. As you can see, beginning from 0, you're having 49 points. Okay. So now if I bring in df here as my data frame, okay. All right. And I run this, I'm going to have a beautiful plot that looks like what you have been expecting. Do we see that? I want to be sure you can see that at your hand.
Yes, sir.
Yes.
You can see it.
And not
see it,
only
yeah.
that, have you also tried it out and also obtained similar results?
Yes, sir. Yes, sir.
It's okay. So if you have done that, I think that's a very good one for us. Thanks, sir. All right. So I think with that, I would like to stop here for today. So I've sent the materials to you. You can engage it, and anything that is not clear to you, please feel free to ask questions on the WhatsApp group. I believe you must have seen by now, if there's something we so much like in the Camda, is that you want to engage us by asking us questions. We really want to help you. We want you to understand this thing. We want you to be able to use it and solve your own problem. We want you to be able to use it to solve Nigerian problems so that Nigeria can be a better place for all of us. All right. So I'm going to be stopping here for today. Anything you don't understand, please feel free to come to the WhatsApp group to ask. And I want to pray that the Lord is going to help us. So thank you so much for your time. Have a wonderful time.
Thank you very much, our facilitator, for that wonderful session. And you will agree with me that that was quite instructive, and that was also quite engaging as well. So yes, I can see those emojis coming up in appreciation to our facilitators, who have done justice to that particular session. Thank you very much, Mr. Samuel Oshikoya, for that wonderful session. So I do believe that during the course of the presentation that we've engaged him through the course. So I don't know if anyone might still have maybe just one question. Well,
I have a question, please.
Okay, we'll just entertain just this one. Thank you. Go ahead, please.
Yes, this color, this one that is, I'm seeing red, and this thing there is not red. I don't know. Is it that if I'm to code, am I to use this number, or I can write the red? And
you can write the
it
red
will give me
actually.
the red color. Type the
You
red.
can have.
And it will give me. Yes.
You
Where
can
your
use the
cursor
red.
is.
You can use the
Okay.
red. Look at it. If I use red, it's going to give me red.
Okay. Yes, sir. That's it. Thank you.
You're welcome.
All right, thank you very much, Patience, for that question. And so just like you've heard our facilitator said that this would be the last lesson on R. So that's also want to tell us that we should go ahead and start practicing on our own. Try to make your timetable with R and see how best you can continue to practice. And if you have any question along the way, somebody's asking that class. And it's not serious, we are seeing the habit. Somebody saying, does it mean we are going to have a teacher? All right, so just be rest assured that you continue to try this from your own end, and if you have questions on what you are trying along the line, can always put up questions on the WhatsApp general group. And I learned that some questions are coming in if the ODE class is going to be hold. Yes, we are still going to hold the ODE class. And again, also the time series class. After now, we'll be going for a short break, and when we return, will be also a session on time series. So we will just stay put, stay on. We'll be having the last session coming up right after now. We'll be having 18 minutes break. 18 minutes break we'll be having after now. So we'll be reconvening by 3 p.m. We'll reconvene for our time series class. Thank you very much for having to stay